Right, a car is travelling in a straight line. It has a velocity of 12 metres per second when passing O. After 18 seconds, the car reaches A, which is 621 metres from O. After a further 12 seconds, the car reaches B, which is 819 metres beyond A. Determine whether modelling the motion as having a constant acceleration is consistent with these values. Okay, so basically what we're going to do is we're going to try to find the acceleration in both cases, and if they're fairly close to each other, then we could say using modelling with constant acceleration would be consistent. So for OA, and we got T is 18, S is 621, and U is 12 metres per second. So if we use S is equal to UT plus a half AT squared, for saying it is a constant acceleration, we've got 621 is equal to U, which is 12, times the time, which is 18, plus a half times A, 18 squared. So that gives me 621 times is equal to 216. A half times 18 squared is 162, and then we're still times A. And then we're going to do 162A is 621 minus 216, which is 405. And therefore A will be 2.5 metres per second squared. Right, for OB, we need to be a bit more careful because T will actually now be 18 plus 12, because don't forget B is beyond A. And that S will be 621 plus 819, which is 1,440 metres. And therefore U will be equal to 12 metres per second. Okay, so now taking my displacement being 1,440, which is equal to the initial speed, which is 12, times the time, which is 30, plus a half times A times 30 squared. So that gives 1,440. 12 times 30 is 360. 30 squared times a half is 450A. So that gives 450A is 1,440 minus 360, which is 1,080. Therefore, A will be equal to 1,080 divided by 450, which is 2.5 metres per second. Well, that's fairly close to that one, and therefore we can say the accelerations are similar values, and so constant acceleration is a good model. I hope you. This has been a video to show you how to find whether a constant acceleration is a consistent model or good model. I hope you've understood, and I thank you very much for watching.